Hi everyone, and welcome to Docker Enterprise Social Distance Learning provided by Mirantis and Stone Door Group. My name is Andrea Alexander with Stone Door Group, and I'll be your host for today's event. Today's topic, Kubernetes tips for better productivity, will show you how to gain an edge on Kubernetes implementation. Our presenters are Amber Ernst, Docker accredited instructor and certified associate at the Stone Door Group, and Bill Mills, head of curriculum development from Mirantis. For those of you not familiar with Stone Door Group, we are a Mirantis solutions integrator and professional Docker value-added reseller specializing in DevOps transformation. We work with companies of all sizes to implement best practices using Docker and Kubernetes. As part of our service offerings, we have two items that may be of interest to those attending today's session. The first is our Docker CE to EE accelerator engagement. This service provides the end-to-end solution for migrating your applications to a secure production environment. In our accelerator engagement, we take care of upgrading to Docker Enterprise Edition and migrating your applications. We do provide all the licensing needed as well as consulting services to ensure you successfully upgrade to EE and have the necessary controls in place. What we have found is that most of our customers have typically implemented CE but are limited deploying to production due to security constraints. So this has been a very successful engagement with our clients who struggle with the choices and options that Docker provides. A typical engagement only lasts around 2 to 3 weeks from start to finish. The second item I wanted to bring to your attention is our free 5-day trial of Docker EE. This is available on our website at the link provided on your screen. And we'll be sending this deck out following today's event so that you have access to these details. You can find out more about Stone Door Group and our offerings at stonedoorgroup.com. There are a few housekeeping items I'd like to cover real quick. If you are experiencing audio issues, you may dial in using the toll-free number provided on your screen. That's 1-888-788-0099, and our webinar ID is 742-327-577. If you need assistance, please contact a member of the Stone Door Group technical support team at webinar@stonedoorgroup.com. Our team members are standing by ready to assist. During today's presentation, we ask that all participants submit questions through Zoom's Q&A feature. You can find this panel on the bottom of your screen where it says Q&A. And just note that this is different from the chat feature. Our instructors are going to collect and respond to questions submitted through the Q&A at the end of the presentation. For those interested, we are recording today's event and we'll be sending out links to all participants for access to the event recording and the presentation materials. If you have questions, we encourage you to reach out to us at letsdothis@stonedoorgroup.com. And just a quick thank you for everyone joining us. Our Docker Enterprise Social Distance Learning series has been comprised of 4 webinars, and this is the final event in our series. We previously learned how to upgrade from Docker CE to EE. We improved Docker administration as well as Docker security. Today's event provides helpful tips and recommendations to improve your Kubernetes implementation. We appreciate your attendance and participation in our Social Distance Learning series, and we hope you'll join us for future events. As many of you may know, we do hold a drawing following each webinar, so I just wanted to provide a quick congratulations to those participants from last week's event who were selected to receive a promotional gift. All of our winners will receive a Stone Door Group t-shirt, and you should be receiving that shortly if you haven't already. Okay, thanks everybody for joining us today. At this time, I'd like to introduce our presenters. Amber is a Docker accredited instructor and certified associate at the Stone Throw Group. She's a subject matter expert on both Docker and Kubernetes and teaches all courses in Docker's official training catalog. Also with us today is Bill Mills with Mirantis. Bill is the head of curriculum development, where he teaches, develops, and maintains the Docker Enterprise Training Stack. Amber and Bill, thank you both for your time today, and I'm going to go ahead and pass the session over to you.
Okay, thank you for that introduction, Andrea. And welcome, everybody. Thank you for joining us today. So it is safe to say that containerization is a prevalent trend in the industry, especially among developers. So when IT executives, when they talk about digital transformation, Kubernetes is typically one of those engines, orchestration engines that's powering many of their initiatives. So digital transformation started with the introduction of containerized environments. This enabled modular, standardized, quickly deployed, and secure workloads. And the rapid expansion of these environments almost immediately lent themselves to needing tools to manage them on a larger scale. So when we work with Swarm, that's one of our very popular orchestrators, right, provided by Docker. But another really popular one is Kubernetes. So in this, perhaps you have already installed Kubernetes in either in development or production environment, and you're looking to see what you can do with it. So in this webinar, we're going to be providing some tips for you to take some full advantage of this for a more productive orchestration environment. So jumping right into this. So first things first, most shells, they allow command completion. It's typically bound to the tab key, and this allows you to complete the names of commands stored upon your path, or file names or directory names. And you can use the autocomplete feature in Kubernetes to fill in long entries automatically. So this kubectl, it provides auto-completion support for Bash and ZSH. This can save you a lot of typing. So let's just look at these steps and then I'll run it through it with you guys. To install, it's pretty simple, and I have more information on each one of these at the very end of our slides, links to do this. But to install it, it is simply a install bash completion. Okay, so this command is actually going to be creating this user share bash completion and the main script of bash completion. It really just depends on your package manager. Then all we do is we reload our shell and we run this init completion. If the command succeeds, we're already set and good to go. So let me show this to you guys, right? So first things first, let me just clear this out. So I'm just in one of my training environments, right? Now to install, remember it is going to be this very simple command, sudo yum install bash completion, apt-get for some of you others. Okay, and yes, we do want to install. That simple, it's completed, right? So then we would echo this source, right? And what we would do after this is we could actually type in init completion and see if this worked for us, right? So if I was just to type in this init completion, here we go. Oh. Aha, gotcha. haven't finished restarting that shell, right? So that's why we're going to get that error. We would restart our shell from here, and then we would get that. So once we've restarted this, let me take you through how we enable this, right? So that's what I was doing next, was I was trying to enable this auto completion. Skipping ahead of myself today. So we need to now ensure that our completion script is getting sourced in our shell sessions. So what we do is we source this completion script in our home bash RC file. We would echo that, and then we would add the completion script to our directory. Now, the next time we open this, it's going to be started automatically for us. And then when we type in something along the lines of kube control and we tab over, we're going to be getting options in regards to auto completing what we need, right? Now, auto completion aside, you know, it's a great little trick, but more importantly, it is necessary, it's extremely important for us to be cleaning up our Docker images, right? We want to prevent our kubelet from getting stressed. So garbage collection, this is enabled by default in our kubelet, and it starts immediately when the var lib our Docker reaches a set capacity, which is at 90%. Now this cleanup process, it only begins when there is not a flag set for kubelet. So I've got a note down here, and that is that there is a lack of a default set for an in-node threshold. That applies to any versions before Kubernetes 1.7. So that makes it essential to add a flag to the kubelet for your users on versions 1.4 through 1.6. So going further into this, since some Kubernetes objects are owners of other objects, an example of this would be a replica set is the owner of a set of pods. The owned objects are called dependents of the owner object. So every dependent object has this metadata.owner reference field, and it points to the owning object. So when you delete an object, you can specify whether the object's dependents are also deleted automatically. And deleting these dependents automatically is called cascading deletion. Now, there are two modes of cascading deletion. That would be our background and our foreground. If you delete an object without deleting its dependents automatically, those are said to be orphaned. Now, these three different ways to delete them, we do this by setting this propagation policy on the deletion request to one of the following options. So for our foreground, we have the object itself not being deleted before all of the objects that it owns are deleted. For our background, the object is deleted, and after this, garbage collection will delete the objects that it owned. And then, of course, we have the orphaned option, right? So the object is deleted and the owned objects are orphaned. So we removed that reference to the owner. So let's go ahead and see how to actually invoke them, all right? I want to make a note here that currently kube control, or kubectl, it doesn't support setting the propagation policy. So I'm going to be accessing Kubernetes API server directly to set the propagation policy. And an easy solution to get access to the API server is via the kube control policy command. This will handle the authentication of our requests. Let me clear this out. Okay, so first off, we're going to create a deployment via kubectl run, right? Just to show this to you. So this will cause the deployment controller to create a replica set with one replica, meaning it's going to start one pod. Created, pretty simple. So let's inspect the owner reference of the replica set. We're just going to use this kubectl git reset. Go look for run my nginx, right? So we can see that this replica set object has metadata.owner references set, and that the owner is a deployment with this name, my nginx. So let's look at the pod that is associated to the deployment. This time we're going to run this kubectl git pod. Okay. And here we can see that indeed the owner is this replica set, right? And it's named my nginx 588d ... right? So let's start that kubectl proxy that I was telling you guys about. Okay. So as that starts, what we're going to do is I'm actually going to perform an example of one of these background deletions. Okay, so this is where the object itself is deleted. And after this, garbage collection will go and delete the objects that it owned. It's a fairly simple deletion. Pretty long command, right? And this is just going to be deleting the deployment itself. Okay. Here we go. So now that we've run this, right, it's going to delete this deployment, and then the garbage collection system will have to figure out that the owner of the replica set is deleted. Then the replica set will be garbage collected, right? So once the command has been completed and we run it, this is something along the output of what we would see, okay? In fact, Bill, what is your experience in regards to these?
Garbage collection is sort of an interesting topic in container management because it really depends on what environment you're thinking of, right? So for a production environment, I usually encourage people to have really aggressive garbage collection policies set. The reason for that is that, of course, you're never going to run anything in production that you don't have backed up a million times other places, right? Both your images and also your kube YAML that you use to deploy that stuff should all be in version control, in registries, so that you can, feel secure in garbage collecting stuff off your production servers to avoid exactly the problems that Amber pointed out, right? I have seen clients take down production clusters by simply running out a disk, right? Sounds simple, sounds silly, but it really happens if you don't think about garbage collection. So set it pretty aggressively in production. In development and testing, so sort of upstream in your CI pipeline, then I usually encourage people to back off a little bit and just provision lots and lots and lots of storage to those development environments where possible, because you're going to have a lot of projects, a lot of experiments in flight, right? And you don't want to necessarily have to rebuild those images just all the way from their Docker files if you lose one of the images you were working on. It's a little bit bigger storage backends for development clusters. But if we walk it all the way back to your development machine, to the Kubernetes and Docker engine you have installed on your own laptop where you're developing this stuff, that's another place where you probably want to sort of back off the garbage collection as much as possible. We don't want to lose stuff, while we're developing things. We want to keep that flexibility and agility of having everything at our fingertips pretty quickly. So, like I said, really depends on environment. The more fast iteration you're doing in an environment, the weaker I usually encourage you to put your garbage collection settings at. Whereas in production, they need to be really aggressive.
Yes, absolutely. And something to note here is that garbage collection, this does take up a significant amount of, you could say even, you know, resource consumption or time, right? So that's something to keep in mind, especially if you have a very heavy garbage collection policies, right? Okay. So from a security standpoint, talking about restricting access seems very intuitive, but this is something that's still very much important to note. So Kubernetes, this is built for cluster deployment across various teams. But this doesn't mean that generic kubectl access should just be given out to everyone. Instead, we should use role-based access control policies anywhere we can, right? This is to grant different access to namespaces that have been assigned to particular teams. So for this example, I'm going to be creating these two namespaces that's going to hold our content. So in this situation, we have an organization and it's using a shared Kubernetes cluster for its development and production. So our development team, they're going to be maintaining a space in the cluster to view the list of pods, services, and deployments they use to build and run their application. Our operations team will be maintaining a space in the cluster where they want to enforce strict procedures on who can and cannot manipulate the set of pods, services, and deployments that run on the production site. There we go. Let me clear this guy out. In fact, still got it running. Here we go. Okay, so first things first, I'm going to go ahead and create this development namespace, right? Now, the pattern for this organization we can follow is just to partition the Kubernetes cluster into these two namespaces, development and production. Now, to create these, I'm going to be setting them up in a JSON file. So first things first, I'm just going to nano into this. I'm going to name this namespace dev, right? We're just going to put in our basic information, okay? Just creating the namespace, naming it development. And to create this, we would use this command. It's going to be kubectl create, and then we're going to create this namespace dev.json. That simple. We've created it. So let's do the same thing for production. Just going to do another, going to nano into another one. We're going to name this one namespace production. Of course, you could do the same thing with VI, you know, Vim. I just prefer nano for this purpose. I'm going to exit out and save. And then we're going to create this one as well with that kubectl create command. There we go. Namespace production created. So let's take a look at these namespaces though. So we would do a kubectl, and we'll just get our namespaces. And let's show their labels. And there we can see what we have created, right? Our development, our production. Okay. Now, one other thing I want to do here, because we've got both of these namespaces created, right? We've seen the namespaces in the cluster and we've confirmed that it looks correct. So this combination of read, create, and delete, these will be granted only to specific namespaces. And this can create a time-consuming process. So we could approach this by creating a role. This permits actions on specific namespaces and grants access to users if needed. Now to do this, we go ahead and we create yet another file. So I'm just going to name this one auth. Okay. And let me put the information in here. Here we go. And as many of y'all know, we have to be cautious on how we have these set up, right? Because if one space is in the wrong place, just forget it. It's not going to run right. Okay. Let me exit out of this and save. Now I'm going to run our kubectl create one more time. And I'm going to create this YAML. Oh, see what I mean? Let's see here. Cluster role looks good. Metadata, name, rules, pods. Let me try this one more time. Here we go. And then bring roles back down. Okay. Ah, that's what it is, API groups. There we go. There we go. So that was created, right? We finished creating that role by running that kube control command. So what we should make sure to prioritize in this process is granting access to secrets for your administrators. This will help you make the distinction between admin privileges for cluster and deployment. But really quickly, I want to point out that with Docker, right, with our Docker Enterprise, they give you the UCP, our Universal Control Plane. And that gives you this graphical user interface where you have the same tooling that is made available. So if we have a UCP, we could just go into there, okay? We would go into Kubernetes and we would create these namespaces in the exact same way, okay? We would just enter in that information from that YAML file and click create, right? So if I was just going to create this guy again, let's see if it'll let me do a repeat. That simple, right? So if you're not, if you're wanting to get away from command line access or you have other users who aren't so savvy to it, you have the same options and capabilities in the Universal Control Panel. These are available to you, thanks to Docker Enterprise. Okay. So before we move forward with this, I'm sure you have more than a few opinions about the importance of role-based access control, right, Bill?
Yeah, definitely. So in addition to giving a GUI and an API that sits on top of Kube's RBAC, the other really crucial thing that Docker Enterprise provides for this is actually a user model, right? So if you look through Kube's RBAC documentation and the demos that that Amber just did, they've got roles and they've got ways to bind those roles to users, but who are the users? Who are they? Right? How do you identify them? You end up having to hand make a lot of key pairs so that you can identify like who's getting these permissions granted to them. Docker Enterprise deals with all that for you, right? You get user accounts that you can either make by hand or populate from an LDAP server. They all get key pairs generated for them. And you can make these roles and then bind those roles onto users, either through the GUI, through the through the CLI or through Docker Enterprise's API, right? So it kind of simplifies finishing the RBAC story, if you will, by giving you that user management piece on top of all that. The other element of users and access control that I think is really important for people to think about is who's allowed to touch different parts of your environment and your CI chain. And what I mean by that is specifically a distinction between users and robots. And my high-level rule of thumb is the closer you get to production, the less humans should be able to touch that cluster or that server, right? By the time when you get completely to production, I usually encourage people to say like no human's user account should be able to deploy to production. That should come ideally at least, that should come at the end of your CI/CD pipeline, and it should be just Jenkins or just GitLab or whatever your CI agent is that's able to deploy to those final clusters. It's the only person the only agent, if you will, that should have permissions to be able to do that. And of course, as you walk backwards through test and development and all that, you can relax things and give people more permissions to deploy to those less sensitive environments. But the reason for this is not just security, but ease of traceability. Right? If it's just Jenkins or GitLab deploying to production, well, of course you have to script that to begin with. So if something goes hideously wrong with that deployment, well, you've got the script that did it. You can do a post-mortem on that and understand really clearly what happened, what went wrong, how to fix it in future.
Yes, absolutely. Okay, so next up, let's talk about adding default memory and CPU limits. So as much as we try and avoid them, mistakes can happen, right? So nodes can crash, memory leaks can occur. This is why default limits are a great tool to help prevent mishaps. This sets a limit. Doing this ensures that connections are closed at a specified point, right? Now, limits, they should be allocated per namespace. Now, to do this, we would do the same thing you saw earlier. We're going to create a YAML file. We're going to add it to the namespace of our choice. And this will apply the limit to all of the containers deployed to that particular namespace. So let's just do that. So if we go to create a namespace, and I believe I already have this guy created, but let's just double check, right? If I was going to name this one default mem example, right? Okay, good, I've got it. So this namespace, the purpose of this one is to isolate the resources that you create from the rest of your cluster. So let's create a limit range and pod. So this YAML file I'm going to be putting in, this is going to show a configuration that specifies this default memory request and memory limit. I'm just going to name this guy memory limits, or memory defaults, excuse me. Okay, so let's put the information into our file. And then let's separate that metadata information. Okay, and everything else looks good in here. Save these changes. Then let's go ahead and apply this. I'm going to do a kubectl apply and apply that memory defaults YAML to that namespace. Created, okay? Now let's do this again. Let's create a limit range in that namespace. So just nano back in, and we're going to call this one defaults pod. Here we go. one second here. We just apply this guy. Okay, perfect. So let's say we want to, you know, from our example, let's say that we have a container and it was created in this default MIM example namespace. And the container doesn't specify its own values for memory request or a memory limit. Then the container is going to be given this default memory request of 256 megabytes and a default memory limit of 512. So let's get that default. Let me just check on this real quick. Yeah, okay. There we go. So to go further into this though, right? The importance of this, right, is just making sure that we have the default memory requests set up for these namespaces. We really want to isolate those resources from our cluster. Bill, in your experience, how often would you say, or how important would you say that these memory and CPU limits are?
They are critically important in all cases. And the reason for that is, think about how Kubernetes manages workloads. I want you to imagine a circumstance where you're running as many pods as you can on your cluster. Okay, so your cluster, all its memory has been taken up by your running workloads right now. Now imagine one of those nodes goes down, right? For whatever, it doesn't matter why, for whatever reason, right? Nodes fail. So what's Kubernetes going to do? It's going to take all the workload that was on that failed node. It's going to try and reschedule it on other nodes in the cluster. But think about what I just said. All your nodes are running at capacity for memory, and now just got a bunch more processes scheduled on it. So what's going to happen? Those nodes are going to fail as they get over-provisioned. What happens when more nodes fail? All their workloads get rescheduled on other nodes in the kube cluster, and you get a cascading cluster failure. Entire clusters get taken out by a failure to impose memory limits and reservations. That's why it's so important to do. Now, you know, I've told that exact same story before in this very webinar series. I tell that same story to all my customers, and still people don't listen, right? People forget, or they don't understand the importance of imposing memory limits and reservations, and so they just don't do it, right? Until they suffer this pain themselves. The beauty of these default memory and CPU limits and reservations is that it's kind of set and forget, right? You can go back to your kube cluster after this webinar right now, go set a default memory limit for all your namespaces, and then if you forget about imposing these memory limitations into the future, well, it's not so bad. You'll still avoid that cascading cluster failure that I described. So it's a good way to think about this once when it's top of mind, set it, and then, you know, have it taken care of into the future.
Yes, absolutely. Setting this and then forgetting it. I mean, it's going to keep you from having probably the nicest way to say this is you're having a bad day if you have a cascading cluster failure, right? A lot of you guys would be having a bad day then. So, so I've got here the list of how this is done, right? How you create that namespace, how you create that limit range in pod, and then how you create that limit range in the namespace. So just really driving that point home. This is so critical. Just do it. Don't avoid it. So next up, let's talk about labels. These are very helpful in accomplishing this broad range of functions, and they're valuable in forming a strong foundation in Kubernetes. They help in loose coupling objects to each other. So creating or attaching Kubernetes labels, this should be second nature whenever new objects are created. Holding regular labeling audits for resources already in operation to ensure they are labeled is also very good practice. So it could slow you down just a little bit in whatever you're currently creating. But believe me, taking this time and labeling as you go, as you work on your project, that pays off later. Now, labeling resources and objects, this will help you avoid Kubernetes production pain further down the line. And it's also going to make it easier to do operations in bulk on Kubernetes objects. Now, one example of this is using a label selector to spin up Kubernetes deployments and services by selecting pods that are based on their labels. Now, in the link, I have an example of common and recommended labels from Kubernetes, so make sure to take a look at that. But one of the beauties of this is it makes it easier to run queries and enables you to use multiple environments in one cluster. So just to show you some of this. So I'm going to create a pod with some labels, okay? In fact, let's just make this example real quick, nanoexample.yaml, right? Here we go. Then make sure that all looks good. Okay. Now, if I want to check that labels are applied in something that's been newly created, right? Well, first we want to apply that YAML, right? kubectl apply. Oh. Let me, Very important to separate that. Okay. We created that. Now let's check that those labels are applied in our newly created pod. So we would just use this kubectl git pod, my pod, and show the labels. There it is, right? Now, if we wanted to add a label to a pod using a kubectl command, we would use this, let's say, kubectl label pod, and I could label my pod, and I could just give it a version ID, right? It's labeled it. Pretty simple to add those in. Now, say we wanted to update a label. I'll show you the command for that as well. Because when aren't people going to decide that they need to update or they need to change something, right? That simple, okay? That straightforward. So Bill, do you have any extra tips or input in regards to labels?
Object labeling is actually a really novel and interesting feature in Kubernetes, in my opinion, especially compared to Swarm. So labels give you this extra degree of freedom that allow you a lot more flexibility in how all the pieces in your Kubernetes cluster fit together. And what do I mean by that? Think about a really simple situation where you've got a Kubernetes service sending traffic to a bunch of pods. Right? So your service is your ingress point to those pods. Now you can put and it matches those pods by label selector, right? So that service is selecting pods that have a particular label on them to know who to send traffic to. Now you can apply the appropriate label to any pods you want. And that lets you create pretty easily some simple network topologies and deployment strategies. Like think about if you wanted to do a canary deployment, right? You could have your stable version of your application in a whole bunch of pods. With the appropriate label to get traffic routed to them by that service. But then you could also apply that same label to just one or two canary pods that you want to put into load balancing and see how they perform before you roll them out fully into production. That's very, very easy to do in Kubernetes because you've got that label selector as an extra degree of freedom between your service and your pods. It's really hard to do the same thing in Swarm. In my opinion, this is one of the simplest and most immediate places where Kubernetes really stands out. In Swarm, if you create a service, the virtual IP assigned to that service is tied explicitly to the containers that sit behind that service. There's no way to add extra containers into that entry point. You're just stuck, right? You rely on some external load balancer to achieve the same sort of canary or blue-green strategy that you can achieve pretty simply with label selectors in Kubernetes. The other place that label selectors are really getting a lot of play right now in Kube is how they get used when building custom resource definitions and kube operators. So when people build kube operators in order to automate the management of a complicated component, like suppose you're deploying like Prometheus and Grafana and Alert Manager as a monitoring stack for your kube cluster. In order to manage the complexity of those tools, they come with a kube operator. We'll manage those things automatically. In order to get your deployments, your pods plugged into monitoring with Prometheus, you can do so by creating fairly simple custom resource objects that are really just pointing Prometheus at your pods by label selector. So you don't really have to understand all the stuff that's going on under the hood. You don't really have to know how to write a Prometheus configuration file. All you need to know how to do is point Prometheus at your pods using a label selector. So it's this kind of common language that's getting leveraged across not just the core Kubernetes components, but all these add-on components that different vendors are making. It's sort of the standard way to tie objects together in Kubernetes.
Yes, absolutely. Okay, so two more things I want to review with you guys here, or show you, right? So I've put this in the slides as you have references, right, on an example of how you would get these commands, get these pods. But let's talk about Minikube. So this is a flexible way to build an application and run it locally. It's very simple to download. The instructions are also straightforward, so that makes it a really popular tool to be using. So after we install it, the command to start it is very simple. It is minikube start, okay, or minikube. So let me show you guys this. Clear this guy at the top. Okay, so what I'm going to do is I'm just going to show you how simple this is to go ahead and download. So we're going to make a directory, right? And then we're just going to use this install minikube. Okay. Now, if we want to see if this cluster is running, right, we would run a minikube status. And we can see that we have it correctly, pointed to the right place. It's up, it's running, it's working for us. So after you've confirmed if Minikube is working with your chosen hypervisor, you can continue to use it, or you can stop your cluster. Now, if we wanted to stop this, we were done working with this. Simple to stop as well. Just be Minikube stop. That easy. Okay. Now, one other thing I want to touch on, and I'll then turn it over and see what Bill's experience is on these as well. But a huge advantage of Kubernetes is that it was created with this modularity in mind. So it can be integrated with a large number of tools and services that have been provided by other vendors. Now, these tools are not created by Kubernetes themselves, but they're recognized on their website. So it's safe to say that you can trust them as much as they do, right? So if you are looking for some tools for troubleshooting and monitoring, we have a Weave Scope. So this generates applications and infrastructure topologies, and this can help your team identify, any bottlenecks. Valero, this is for overseeing our disaster recovery of Kubernetes resources and volumes. So it'll provide this simple way for you to back up and restore these. For our developers, Helm is a package manager for Kubernetes, and this allows you to create these reproducible builds and then manage them and manage your Kubernetes manifests with ease. And then we have Compose. So this would allow you to seamlessly transition Compose files and applications into Kubernetes objects. So that's a great tool for developers who are experienced when it comes to container management, but you don't know Kubernetes very well. And then the last up is for testing, and this would be KubeMonkey, right? So that's a tool that follows the principle of chaos engineering and tests fault tolerance by randomly killing pods, okay? So there are so many other options that are available if you're looking for some more plug and play options for your Kubernetes deployment. Bill, what's your experience when it comes to Minikube and these other third-party tools?
I would really highlight specifically Minikube and Helm should be part of everyone's tool chain. So particularly for developers, if we want to think about productivity improvements and making sure we aren't hitting speed bumps we can avoid, one thing you really want to try and do is match your environments across your chain. So that means from your development machine through CI pipeline onto production, you want to be running the exact same version of Kubernetes everywhere. Otherwise, you'll get API differences, performance differences. Things will look nice when you're developing it and maybe not work so well in production. Minikube is probably the best, most vendor agnostic way to get yourself a Kubernetes deployment that you can run right on your development machine and match it to the right version of Kube that your ops team has decided to run in production, because you just get the appropriate version of Minikube, come with the right version of Kubernetes. There's of course other options out there, right? Docker Desktop will set you up the Docker engine and a Kubernetes deployment all in kind of one stop. It more tightly couples the version of Docker with the version of Kubernetes in Docker Desktop, so a little bit less flexible there. That's why I kind of prefer Minikube for getting a really well-matched environment across my pipeline. I mean, a bunch of vendors have other solutions, right? You got K3s from Rancher, you got micro-K8s from Canonical, right? So if you've got relationships with those vendors, by all means. But really, Minikube is the most vendor agnostic, flexible way to get a Kubernetes deployment stood up on your machine, your development machine. And this is really critical, right? It's really important not just to have a Kube version that matches environments across your CI pipeline, but you really want to have a fully featured orchestrator available in your development environment. A long time ago, like 5 years ago, it was really hard to get Kubernetes installed. It was really hard to get Docker Swarm bootstrapped. And so that's why people really relied on toy orchestrators like Docker Compose to have some simple orchestrator they could use in their development environment. Thanks to Minikube, it's so easy to get a fully featured Kube deployment set up on your development machine. I really strongly encourage developers, this should be like the first thing you set up when trying to develop for Kubernetes. Don't rely on toy orchestrators. Don't rely on having to deploy to a cluster that you might not control all the details of, right? Get yourself Minikube or Docker Desktop or some Kubernetes deployment you can run locally so that you can really test your orchestration but in your inner loop of development before sending it off to CI. That's Minikube and friends. Helm is another critical component that I really want people to think about when developing their Kubernetes applications. The key problem, the reason that I think Helm or a tool like it is so important is that by default, kube-YAML is not templated. Right? You can't put like an environment variable in there and have it change based on your environment at runtime. It's just a static YAML file. One of the most important things Helm offers is a templating engine, right? So you can have, your YAML broken out with template values in them, and then you can change those values depending on what environment you're running in. So there's very little re-engineering that needs to be done when you move your app from your laptop into your test servers into production. You just change a few variables in the Helm variables file. Of course, Helm's not the only templater out there, but That combined with its ease of updating applications and versioning Kubernetes applications makes it, I think, the most production ready, most like stable and substantial package manager out there for Kubernetes. We should be engineering our applications with Helm in mind from the beginning. It's also really easy to get installed on your laptop as well. So there's really no blockers there.
Yeah, absolutely. Absolutely. I couldn't agree with you more. Okay. So in conclusion, Kubernetes, this is a popular choice for orchestrating your containerized environment, right? With its modularity, its large community, and this expanding selection of third-party tools, it's no secret as to why. So hopefully these tips give you a good starting point when you're really planning out or you're working on your deployments. Now, just a refresher to us as to who we are. We're Stone Door Group. Well, I'm an instructor from Stone Door Group, and we are a Maranta Solutions integrator and professional Docker value-added reseller. So we specialize in DevOps transformation. We work with companies of all sizes to implement best practices using Docker and Kubernetes. Now, if you're with us because you're looking to take your Docker setup to the next level, we have these items that may be of interest to you. So we have this Docker CE to EE accelerator engagement. Its service provides the end-to-end solution to migrate your applications to a secure production environment, and we take care of upgrading you to enterprise and migrating those applications. We provide the licensing needed and the consulting services to ensure you successfully upgrade. We get you where you want to be. The second one I want to bring to your attention is the free 5-day trial of Docker we have available. So this is available on our website at the link on your screen, or if you already have an environment up and running, just use this command right here, our coffee command. So this leaves us a few minutes for some Q&A. Let's go ahead and get right into that, right, Bill?
Absolutely. I've got a bunch of answered questions here, so why don't we both just scroll these and pick a few out.
Yeah.
Tell me if anything catches your eye here, Amber.
Sure thing. Okay. Okay, so.
Okay, there's one important clarification, I think. So Jerry asks, if our developers don't set default memory limits for their pods, how can we set up system reservations to prevent Kube from eating up all memory on machines like I was talking about? It's really important to understand what Amber was describing was exactly that default memory reservation. And that's typically the responsibility of your operations team to impose that baseline default reservation on your production clusters at least, to solve exactly the situation Jerry's worried about. What if developers just forget or just didn't know they needed to impose some memory reservations in their kube YAML? So that default that Amber was describing deals with exactly that. There's another question in here that was asking about priority for reservations. If a developer doesn't forget to define a memory reservation for their pod or memory limit, same thing for CPU, that will take precedence, right? So the specific one defined for a pod will take precedence over the default reservations.
Yes, yes. Let's see here. Alexander had asked, when a label is assigned or changed, is it being logged somewhere? So, it's possible to track this in future if you need to audit this. And yes, so you could check the logs of the Kube API server. I saw that Bill touched on this. So UCP, it logs all of these API requests in its audit logs when it's enabled. So you have this specialized logging function where you can go in and you can see everything that has been done in there.
Make sure you turn it on, though. I believe it's disabled by default in UCP. So turn it on and turn it up as well. There's like a few different logging levels. I like to set it, pretty aggressively to log lots of stuff for exactly the reason behind that question, right? You always want to be able to do postmortems on your systems, right? So you understand exactly where changes came from. Another way to deal with this, like suppose you're not using UCP, so you don't have UCP's audit logger available. A great pattern for managing your Kubernetes clusters, again, particularly in production where you really have to be able to do this auditing, is like a GitOps flow. And the idea behind GitOps is that you never hit kubectl directly, ever. Right? You ever want to do anything on your Kubernetes cluster, you commit it to a repository, a Git repository. And then you've got some agent monitoring that Git repository and making your cluster match the state that's described in that Git repo. Doesn't really matter what the agent is, right? You can do it with Jenkins, you can do it with GitLab. A Flux is a great kind of kube native tool for doing GitOps like that. But the point of this, or the reason I'm bringing it up in context with this question, is because of the indelible history of a Git repo, you can always do that post-mortem. You just look at your commit history to see, who changed what when. Right? That way you always have logs of every change made to your Kubernetes cluster.
Yes, absolutely. Let's see here. This is a really short and simple one, but just to share this with everybody, can we have pods under multiple namespaces? Well, one pod lives in exactly one namespace. Bill put it pretty succinctly. So
I actually really like that about Kubernetes, that its namespace structure is very simple. I think we talked about this in our last webinar last week, actually, that Kube on purpose has no concept of nested namespaces, right? Like a namespace inside a namespace. No, that never happens in Kube, as opposed to resource collections in UCP. This makes it makes RBAC really easy to understand in Kube, because you only have to look at the rules for the namespace that an object lives in, right? You don't have to be like, okay, well, that's the rules for this namespace. Are there other namespaces that affect this object? No. The answer is always no, right? There's only one namespace that affects a given object, and that's the only place you have to look to understand rules that affect that object. There's a good question from Ashok here. What's a good tool to monitor system metrics for all these different things in Kubernetes? I am a huge fan of Prometheus. So if you have a look, Prometheus offers a Prometheus operator with a bunch of custom resource definitions that you can deploy via Helm really easily. It's like a one-line command. And you get not just Prometheus, but also Alert Manager and Grafana. Not only do you get those tools deployed on top of your Kubernetes cluster, you also get a bunch of presets. So if you go into the Grafana dashboard, there's a whole bunch of different predefined dashboards optimized for monitoring Kubernetes. You can also create custom monitoring from that stack just by some of those simple custom resource definitions that I was describing earlier. So all you got to do once you've got Kubernetes and Helm installed, just go have a look at the Prometheus operator and Helm chart, deploy that one-line command, and you've got an excellent production-grade monitoring stack deployed on top of Kube for you.
Yes, absolutely. And this is another reason I like to tell people, I like to really say, try out Enterprise, try out the Universal Control Plane. Because if I was to slide back into this, right, and I go to our dashboard, this is Prometheus right here actively working and showing us the state of everything right there in front of us. Okay? And that is built in, like Bill was saying, it's built in there for us.
Yeah, absolutely.
Yeah. Let's see here. We've got one more minute. Let's see if we've got any others we can grab. Okay. We had a new one here. Tajinder, can the default resources be given as a percentage of available resources, or does it need to be already given in absolute numbers? What would your opinion on that one be, Bill?
I've always, to be honest, I've never tried to assign it relatively like that. I always have assigned it in just absolute numbers because that's how I think about the amount of resources my process needs. It's like, if I've got something that I expect to allocate 2 gigabytes of memory, well, I expect it to allocate 2 gigabytes of memory, whether that's the entire RAM of the node it's running on or 1% of it, I don't really know, right? And as a developer, I kind of can't know, right? I don't know where this pod is going to get deployed to. I don't know what size of resources is going to be available there.
Yep. And speaking of learning more about all of this.
Yes, excellent. So that's where top of the hour now, folks. We kind of went through a smorgasbord of different ideas and tools for leveraging the most you can out of Kubernetes. If you want to go through even more of these ideas in a hands-on environment where we get to try these out all ourselves, I encourage you to have a look at Mirantis' training program. So Mirantis training, delivered by our awesome partners like Stone Door Group and Amber, takes all the best of what we learned from our field team, working with customers like you, and turn that into hands-on workshops where you're actually going to get to try all this out over the course of a few days in class with our Stone Door instructors. Let's have a look at our Docker classes. So on the Docker Enterprise side of things, we've got a series of courses that'll take you from your first encounter with containerization all the way through day 2 operations and support for Docker Enterprise. If you're not a Docker Enterprise customer, you prefer vendor agnostic Kubernetes, we do that too, of course. Have a look at our Kube courses. There we go. We've got a series of Kubernetes courses that'll take you through, again, same story, right? The basics of the first time you've ever seen Kubernetes, all the way through to advanced troubleshooting and cluster management.
Great. Well, thanks, Bill and Amber, for another fantastic presentation. I wanted just to send out another quick congratulations to those participants from last week's event who were selected from our drawing. All of our winners will receive a Stone Door Group t-shirt, and you should be receiving that shortly if you have not already. Thanks again for everyone's attendance today for Kubernetes tips for better productivity. This does conclude our series for Docker Enterprise Social Distance Learning. A quick reminder on a couple service offerings mentioned earlier: our Docker CE to EE accelerator engagement provides the end-to-end solution for migrating your applications. Typically takes around 2 to 3 weeks from start to finish. And then we have our free 5-day trial of Docker EE available on our website. Following today's presentation, you will receive an email providing a link to the recorded session and the presentation materials. So you will have access to all these details directly. And at the close of today's presentation, you're going to see a survey poll. We do ask that you take a minute to answer 4 brief questions to help us improve future presentations. Thanks again to our presenters Amber and Bill, as well as all of our participants for taking the time to join us. Again, please feel free to reach out to us at letsdothis@stonedoorgroup.com. Thanks again, and we hope everyone has a great day.